And we're gonna pick up right where we left off. So we finished order of operations, and now we're gonna jump into solving linear equations. Okay, so on these, we are going to be solving for x. So we're gonna start with number 16. Okay, so I'm gonna write it out here since there's little space in between each problem. So 5 times x minus 2 equal to 4x minus 10. Okay. So in order to solve for x, the first thing we're going to need to do on the left side is distribute this 5 into the parentheses. So it's going to be 5 times x minus 2. So we shall get 5x minus 10 equal to 4x minus 10. So the right side stays the same. We distribute the 5 on the left side. Okay, now we want to put the x's on one side and the constants on the other side. And a constant is just a number. So 10 would be a constant. Okay, so what I'm going to do is move this 4x over to the left. So minus 4x minus 4x. And in the same move, since I want to get that 10 to the right side, I'm going to add that 10 over. Plus 10, plus 10. And let me draw my little process line here. And these 10s cancel, these 4x's cancel. And with our 5x minus 4x, that leaves me with x. And then negative 10 plus 10 leaves me with 0. So look at that. All of that work for 0. Okay, everybody good with that? Let me do that. Okay. Again, 17. We have 2x minus 5x equal to 3 times 2x minus 4. So this is just like 16. Now, in order to solve for x, we need to distribute that 3 on the right side. So we're going to distribute this 3 into the 2x and to the negative 4. And also, on the left side, since these are the same, have the same variables, since they both have an x, 2x minus 5x, we can subtract those two and I'll get negative 3x equal to 6x minus 12. Okay, and then I'm going to move that 6x over to the left. I'm going to subtract it. So minus 6x minus 6x. Put my little line here. And we are going to get negative 3x minus 6x, which will give me negative 9x equal to negative 12. Okay, now we're solving for x. We're still solving for x. We need to get x by itself. So the next move is to divide by negative 9. We divide by negative 9. And I'm going to be left with positive x equal to, and negative over negative makes positive, and you're going to get a positive 12 over 9. But we can reduce that. What does 12 over 9 reduce to?
4/3.
4/3. There you go. X equals 4/3. All right, not bad. All right. Can I share the screen? You should be able to see them. You might be clicking the wrong cloud recording, because what you're looking at now that I'm sharing is what you should be able to see in the cloud recordings. And I also posted them into our modules as well. So if you go to our modules and look up our order of operations, you should be able to find the video there as well. All right. 18. Okay, so 18, 10x plus 4 minus x equal to 7x plus 2 times 3x plus 5. Okay, so we have some cleaning up to do on the left side and the right side. So on the left side, since we do not see a number out here, outside the parentheses, since you don't see a number there, it's assumed to be 1. So all you have to do is distribute that 1 into the parentheses, and you're going to get the same exact thing. We'll get 10x plus 4 minus x on the left side. Then on the right side, we're going to have to distribute this 2 into those parentheses. So you end up with 7x plus 6x plus 10. And now we have distributed on the left side and the right side, and we will combine like terms now. So on the left side, we have 10x, negative x. We can combine those since they have the same variable. I'll be left with 9x plus 4. On the right side, we have 7x and 6x. Again, same variable. Add the terms up. 13x plus 10. Okay. And now we need to have x on one side, the numbers on the other. So what I'm going to do is move this 13 to the left, move that 4 to the right. And I'm going to say minus 13x minus 13x. In the same move, I'm going to do minus 4 minus 4. All right. Do my process line, and my 4's cancel here. My 13x's cancel there. And what I'm left with is 9x minus 13x, which gives me negative 4x. Equal to 10 minus 4, we get 6. Okay. Now, solve for x, divide by negative 4. And we are left with positive x equals negative 6/4, which can reduce. And what does negative 6/4 reduce to?
3/2.
Negative 3/2. There you go. Cool. All right. Any questions on those 3 so far? All right. All right, 19. I can move over. Let's see. There we go. Get all that room going. Okay, 19. We have 3 minus 2 minus 7x equal to 2x minus negative 5x minus 1. All right, just like the others, we are solving for x. So what we're going to do now in 19 is distribute these negatives. So again, since you do not see a number in front, we can assume there's a negative 1 in front and just distribute it to each term. Same thing on this side. Distribute that negative into the parentheses. All right, so distributing that negative, you'll have 3 minus 2 plus 7x equal to 2x plus 5x plus 1. So positive 5, positive 1, negative 2 plus 7x. Okay, so we have distributed again, and now we just clean up. Combine like terms. Left side, only the numbers are similar, are like terms. And on the right side, my x's, 2x and 5x. So let's combine those. 3 minus 2 gives me 1 plus 7x. And on the right side, 2x plus 5x gives me 7x plus 1. Ooh, nice. Okay. So now put your x's on one side. I'll move this 7x over, and I'll move this 1 over that way. All right, so let's see what happens. I'm going to say minus 7x minus 7x. And then I'm going to say minus 1 minus 1, all in the same move. Didn't like that line. And here, my 1's cancel, my 7x's cancel. And then over here, my 7x's cancel and my 1's cancel. So what am I left? What number am I left with on the left side and the right side?
Isn't it 0 equals 0? But there's a specific term for that, isn't there?
There is. You get 0 equals 0. Well, first off, is that a true statement?
Yes.
Yeah, 0 equals 0 is a true statement. And if this ever occurs when you are solving equations, this means that no matter what number you plug in, you are always going to get a true statement. So what this also means is that since any number works, this also means that there are infinitely many solutions. So if you ever come across 0 equals 0, your answer is infinitely many solutions. This means whatever number you plug in, you're always going to get a true statement. So pick whatever number you want and play around. Okay, awesome. Then let's look at 20. Back to blue. There we go. All right. 20. 3 times t minus 7 over 2 equal to t minus 6. Okay. So here we need to solve for t, but we have to get rid of this pesky 2. Anybody know what to do with it?
Multiply it
Multiply it. Where?
on both sides.
Good. You can multiply the 2 on both sides. I like that. So let's say that we multiply this side by 2. And then we multiply this side by 2. Well, if we do that, this 2 and that 2 will what?
Cancel each other out.
Cancel. Very good. That 2's gone. That 2's gone. So all we're left with is, on the left side, is 3 times 2 minus 7 equal to, and then on this side, you can distribute the 2. But let me rewrite it step by step. So t minus 6 times 2, I'm just going to rewrite it as 2 times t minus 6, just to work it step by step. Okay, now let's solve for t, meaning let's distribute the 3 and let's distribute the 2. 3t minus 21 equal to 2t minus 12. And now solve for t. I am going to move 2t over to the left, minus 2t, minus 2t, and then add 21 over to the right. Process, and 21s are gone, 2t's are gone there, And what I'm left with is 3t minus 2t gives me t equal to negative 12 plus 21 gives me positive 9. And that's it. All right. Any questions on that? And always, of course, there's another way to handle this. If I rewrote this, all you have to do is take this 2 and multiply it to the right side. And we're there. So that's another option as well. Okay. Sweet. All right, what's next? 21. Yuck. All right, 21. 6/7 plus x equal to 13/7. Oh, this one's not bad at all. Okay. So all you have to do here is solve for x. So you just take the 6/7 and subtract it to the right side. Hey, that's not bad at all. So I'll say minus 6/7 minus 6/7. Draw my process line here. And all we're left with is x equals 13/7 minus 6/7, which gives me 7/7, which is also what number?
1.
1. All right. Cool. All right. So that was 16 through 21 so far. How are we doing? If you're good, show me those thumbs. Let me know you're alive. All right, there we go. Sweet. Okay. Cool. All right, and I think I can move back to writing on the paper now because there may be room here. I think I just have to zoom in a bit. Yeah, all right. And this is there, and go to view, and let's zoom, all the way zoom. Maybe one more. There we go. Perfect. That's a lot of room. Okay, and then back there. All right. 22, same stuff, just like 20. Well, no, not like 21, like 20. X minus 2 over 3 equal to x minus 1. What could I do with that 3?
Multiply.
Both sides.
Just multiply to the right side. That's all we have to do. Save us some time. If we multiply the right side, you will be left with x minus 2 equal to 3 times x minus 1. Beautiful. And now distribute the 3. X minus 2 equals 3x minus 3. And now put your x's on one side. And again, it doesn't matter. You can put your x's on the left. You can put your x's on the right. So let's go ahead and practice by putting the x's on the right side. Why not? I'll take this x, move it to the left. And then I'll take this 3 and add it to the right side. And x's are gone, 3's are gone. Now, negative 2 plus 3 leaves me with 1. And 3x minus x is 2x. Divide by 2. And we get x equals 1/2. half. All right. Not
I have
bad.
a question.
What's up?
On the homework, if we're solving something, but it doesn't have an equal sign, and then it kind of turns into a polynomial, do we factor it?
No,
Trying to-
just
No?
simplify it. But yeah, do not factor because we haven't learned factoring yet. But if you know factoring, cool.
Okay, cool. Thank you.
Yeah. Okay, that was 22. Now 23, 2/5 x minus 5/7 x equal to x minus 1. Oh man, look at all those lovely fractions. Okay, do you guys want to work with the fractions or do you want to get rid of the fractions?
Whichever's on the exam.
Get rid of the fractions. Okay, so if you want to get rid of the fractions completely, then this means we need to find the common denominator. What is the common denominator between 5 and 7?
Five.
Not 5.
35.
35. There you go. 35. So if we're going to get rid of fractions completely, this means you need to multiply the whole equation by 35. So that's what we're going to do. Whoops, no, keep that and that. Let's do that. So we're going to say 35 times, and the equation, 2/5 x minus 5/7 x equal to 35 times x minus 1. Okay, so to get rid of your fractions, you multiply by the common denominator of both fractions. So now this 35 is going to distribute to both of these terms. So 35 times 2/5. Can we cross cancel that?
Yes.
Yes. 5 goes into 35 how many times?
7.
7. And then you're left with 7 times 2, which gives us 14. So this means for the very first distribution, we are going to get 14x minus, let's do it again, 35 times 5/7. We can cross cancel this one, just like the last one above. 7 goes into 35 5 times. Here you are left with 5 times 5, which gives us 25. So for the second distribution, we are going to be left with negative 25x equal to, and now these ones are easy, 35 times x, 35 times negative 1. 35x minus 35. And look how nice that is. No more fractions. Look at that. Okay. Now, of course, we still have to clean up. So on the left side, we have our common terms, 14x and negative 25. On the right side, we don't have anything. That's 35 and 35x and 35. They don't have anything in common. Okay, so 14x minus 25x gives me negative 11x equal to 35x minus 35. And now we're solving for x. So I'm going to move this 35 to the left. So subtract 35x, subtract 35x And I will move it over here. Boom. Okay. Negative 11 minus 35 is going to be negative 46x equal to negative 35. Okay. Now, just divide by negative 46. Divide by negative 46. Divide by negative 46. And we get positive x equals positive 35 over 46. Can we break that down? I don't think so, right?
Yeah, I don't think so.
Because 35 is 7 and 5, 46 is 2 and 23. So nothing's going to happen there. Okay, and there you go. That is a nasty answer, y'all. All right. Any questions on that one?
Hello. I have a question.
Yeah, what's up?
So if because I know like that fit perfectly, the 35 into the 2 or 5 and 5 over 7.
Mhm.
What would you do if we didn't have like a common denominator or anything? Like how would you solve it for the fraction itself?
Like if you didn't want to do this common denominator process,
Yeah.
then you would just, you would work with these fractions separately. So
Okay.
you would still have a common denominator no matter what between two fractions. But if you didn't want to clear your fractions, then I would multiply 2/5 by 7 over 7. And I would multiply 5/7 by 5 over 5.
Okay.
Or so that's another way to handle that.
Okay, thank you.
Mhm. Yeah. Cool. 24. Let's keep rolling. We have 10x minus 4 minus 3x equal to 7x plus 2 times 3x plus 5. So here we distribute the negative to the 4 and to the negative 3, and the 2 to the 3x and to the 5. So this leaves us with 10x minus 4 plus 3x equal to 7x plus 6x plus 10. Okay, we distributed the left, distributed the right, combine like terms, left side 10x, 3x, right side 7x, 6x. And the left side 13x minus 4, the right side 13x plus 10. Okay, now we're going to take our x's, move them to one side. I'll bring this 13 to the left. I'll add that 4 to the right. All right. Minus 13x, minus 13x. Add the 4. And then process. 4's gone, 13's gone. And actually, those 13's are gone. So the left side, we are left with what number?
6.
If everything canceled out on the left side.
14. I'm sorry, 14.
Oh, that's going to be the right side.
Yeah. It's
So if everything canceled out here on the left side, what number represents nothing?
0.
1. No, 0.
It's 0. There you go. equal to, and now on the right side, you have
14.
14. Okay, so 0 equals 14. What's up with that statement?
That's false.
That is a false statement. 0 does not equal 14. This is false. So the last one, we got 0 equals 0, which was infinitely many solutions. This one, we get 0 equals 14, which is not true, which means how many solutions do we have?
None.
None. So we say no solutions. So now, if you pick any X number, no matter what, the equation is always going to put out a false answer. Okay, no solution. Cool. All right, 25. Whoa. All right, 25. 4 minus 1/3 times 2 minus 7x equal to 2 times x minus 1. So let's go ahead and distribute that 1/3 there and there. And we'll distribute the 2 at the same time. So 4 minus and negative 1/3 times 2 is a negative 2/3. And then negative 1/3 times negative 7x gives me a positive 7/3 x. And then on the right side, that is just 2x minus 2. Okay, so let's have fun with this. So on the one of the last problems, the one above, directly above this, we cleared fractions. So let's practice this without getting rid of our fractions. So let's put our x terms together and all the other numbers together. So first off, let's go ahead and put these two terms together. 4 minus 2/3. If I want to put these two terms together, what do I do?
Find a common denominator.
Find a common denominator. Good. I can put 4 over 1, and my common denominator is what?
12.
3. Between 1 and 3.
Oh,
That's it.
yes.
There you go. So we multiply that by 3 over 3. We end up with 12 over 3 minus 2 over 3, which gives us 10 over 3. Also, remember your fraction trick, y'all. What's 4 times 3?
12,
What's 12 minus 2?
10.
10/3. Look at
I have another question.
yes.
Okay, so did you remember how you said we could find the answers to our homework to check our work in the back of the textbook?
Mhm.
I couldn't find them. Like, are they labeled? Because they just had like a bunch of answers, but I didn't see like the name of our homeworks. Like,
It'll
maybe I
say
wasn't
the
looking
name.
properly.
Yeah, it'll say like fractions, application with a fraction, stuff like that.
Gotcha. Okay.
Yeah. So just look again. Okay. So 10/3 plus 7/3 x equal to 2x minus 2. Okay. So now we'll put our x terms together and we'll put our constants together. And remember, constants is just a fancy word for number, just a regular old number. Yes, a fraction is a number. All right. So I'm going to say minus 2x minus 2x. And in the same move, I'll say minus 10/3 minus 10/3. There's my process line, but it's going to be, I'll just leave it there, but we'll move to the right. Okay, so we still have some fraction work in front of us. So what we're looking at first, well, hang on, let me cancel these out and those out. So what we're looking at first is 7/3 x minus 2. So 7/3 minus 2. And just like the above, you put 2 over 1 and get that
1/3.
common denominator of 3. What's up? Are we good? And that becomes 6 over 3, which gives me 1/3. So that's what we're going to start out with. So we will have on the left side 1/3 x equal to, now on the right side, you have -2 minus 10/3. So -2 minus 10/3. You put 2 over 1 again.
Yeah, -16/3.
Good. Get that common denominator of 3. And -6/3 minus 10/3, I just heard, gives us -16/3. So that's what's going right here. Ooh, man, good stuff, right? Okay. So now we need to solve for x still. So that means I can divide by this 1/3, or to make it easier, you can multiply both sides by the reciprocal of 1/3, which means to get rid of that 1/3, we can multiply both sides by what number?
3 over 1.
3 over 1. Good. Here, I'll do that. I'll do 3 over 1 on this side and 3 over 1 on that side. And over here, 3's cancel, and you are left with x on the left side. On the right side, 3's cancel, and you're left with x equals -16. Oh, man. Good times. All right. That was what? 22, 23, 24, 25. How we doing, y'all? Good. All right. All right. All right. Sweet. Okay. Let's keep rolling. 26. Just like 22 above. So 4 times x plus 9 over 3 equal to x. So we've seen it before. So let's just take this 3, multiply it to the right side. If we do that, we end up with 4 times x plus 9 equal to 3x. Then distribute the 4. 4x plus 36 equal to 3x. So distribute the 4 and then put your x's together. Let's say minus 3x minus, actually, I can move the 4 over, sorry. I'm going to move the 4 over instead, since there's an x over there. I'm going to say minus 4x minus 4x. And 4x is canceled there. I'm left with 36 equal to -x. And all we have to do to solve for x is divide by -1 or multiply both sides by -1. And that will give us -36 equals x. Okay, not bad. Okay. Yeah, okay. 27. 6 over 11 plus x equals 11 over 7. All right. So for this one, all we have to do is subtract that 6/11ths. Say 6 over 11 minus 6 over 11. Move that to the right side. There we go. And let's look at the fractions. I don't know why I'm writing in red, but I guess it makes sense for side work. So if I look at this one, 11/7 minus 6 over 11. What is the common denominator between 7 and 11?
77.
77. So this means we multiply this guy by 11 over 11. And we multiply this one by 7 over 7. And what is 11 times 11?
121.
121 over 77 minus 42 over 77. Okay. And what is 121 minus 42?
$30.
121 minus 42.
79.
79 over 77. There we go. And we end up with x equals 79 over 77. And I do not think you can reduce that, can you? Okay. Awesome. So let me zoom out for a bit. That was, oops, sorry. Let's see. There we go. That's better. That was the rest of them, 22 through 27. So any questions on those before beginning part C? All right, everybody's good? Okay, cool. All right. Now, for this part, we have linear expressions and equations, and knowing the difference between both is very important. And the main thing is, if you have an equation, this means you have what symbol?
Equation, you have an equal sign.
An equal sign. So that's the biggest difference. And equations you solve, expressions you simplify. So expressions can only be simplified and equations can only be solved. And equations have an equal sign. Okay, that's the big difference. So number 28, it has x over 3 plus 1/4 x minus 1. Expression or equation?
Expression.
expression. So let's go ahead and simplify this. So we want to put all three terms. We want to put all three terms together. So let's go ahead and simplify this expression. So I'm going to rewrite it first as x over 3 plus 1/4 x is the same as x over 4 minus 1. All right. And now, if we want to put all three terms together, we need to find a what?
Denominator.
Common denominator. What is the common denominator between 3, 4, and 1?
Well,
12. Good. So this means that x over 3 gets multiplied by 4 over 4. X over 4 gets multiplied by 3 over 3. And 1 over 1 gets multiplied by 12 over 12. Okay. And here's what we have. 4x over 12 plus 3x over 12 minus 12 over 12. Now, all three terms have the same denominator. This means we can simplify the numerator. What is my final answer?
Seven x minus 12.
All over 12. There you go. All right. And that's how you work expressions. You simplify them as much as you can. Okay. 29. X over 3 plus 1/4 x equal to 1. Well, definitely an equation. Okay. Now for this one, you have a choice. Again, work with the fractions or eliminate your fractions.
Work with them.
Work with them. Okay, cool. So if we work with them, this means you have x over 3 and 1/4 x. And just like the last problem, what's our common denominator?
12.
12. So we multiply this by 4 over 4. We multiply this one by 3 over 3. And we end up with 4x over 12 plus 3x over 12 equal to 1. Okay. Now you have 4x over 12 plus 3x over 12. Putting those fractions together gives me 7x over 12 equal to 1. Now, how do we solve for x?
Multiply by 12.
Multiply by 12. Good. So we're going to multiply this 12 to the right side and end up with 7x equal to 12. Then divide by 7. And x will equal 12 sevenths. All right, cool. Not bad, guys. All right, 30. X over 4 plus 3x. Once again, there's no equal sign. So this is an expression. And if we want to put these two together, once again, we're going to need what type of denominator?
Common.
Common. Put this 3x over 1, and what's my common denominator between 4 and 1?
4.
4. Multiply that by 4 over 4, and we get left with x over 4 plus 12x over 4. Now these have the same denominator. You can add your numerator, and what's my final answer?
13x over 4.
13x over 4. Perfect. All right, cool. And now, equation 31. 5x minus x minus 3 equal to 7 plus 2 times x plus 6. Okay, so first thing we're going to do, distribute that negative. 5x minus x plus 3 equal to 7, and then distribute that 2. Plus 2x plus 12. Okay. Combine like terms. 5x, negative x, and then on the right side, 7 and 12. So on the left side, we'll have 4x plus 3. On the right side, 2x plus 19. I'm going to move the 2x to the left, the 3 to the right. Let's go. Minus 2x, minus 2x, minus 3, minus 3. Threes cancel, 2x's cancel, and 4x minus 2x, we get 2x equal to 19 minus 3, 16. Divide by 2, and x is gonna equal what?
8.
8. Good. X equals 8.
I have
Yeah.
a question.
What's up?
When two numbers are multiplied, if they have exponents, the exponents are added, right?
As long as they have the same base, yes.
Okay.
Is that what we're working on now, or is that a question for after?
Oh no, I have a question on the homework because I don't know, I'm confused by the answers. I'm like, how
Oh.
did you get that? Because they have like 3x squared, but when you multiply them and like do the box method or whatever, the biggest number you get is like 2x to the fourth.
All
So
right.
I'm just wondering how they
Okay.
got that.
We can handle that when I'm done here. So
Okay, cool.
let me finish up here, and then
Gotcha.
definitely leave it open for homework questions. Okay. 32. You have 3 times x minus 3 over 2 minus x. So this is definitely an expression, no equal sign. So we need to put these terms together. So fair enough. All we have to do here is put this x over 1. And what is our common denominator between 1 and 2?
2.
2. So multiply this by 2 over 2. And I'm just going to write this step by step. You have 3 times x minus 3 over 2 minus 2x over 2. And now we can simplify more. We have the same denominators. You can simplify the numerators. Go ahead and distribute that 3. And we get 3x minus 9 over 2 minus 2x over 2. And now put them together. And 3x minus 9 over 2 minus 2x over 2. What is my final answer?
Would it be x minus 9 over 2?
Very good. x minus 9 over 2. Okay.
How did you get that?
From how do we get the final answer?
Yes,
So we see they have the same denominator, right?
right.
That means you can put the numerators together. So if I did one more step, I would rewrite this as 3x minus 9 minus 2x over 2. And then what is 3x minus 2x?
1.
1x, right?
Right.
And we'd be right there again.
Okay, got it.
Got it?
Yeah, I was like, what?
Awesome. All right, cool. And then 33. This is just like all the other ones we've seen today. What do I do with that 2 in the denominator?
Multiply it.
Multiply it to the right side. Let me change colors. Bam. Multiply that to the right side, and the left side is 3x minus 3 times x minus 3 equal to 2x. Distribute that 3x minus 9 equal to 2x. And then I'll move this 3x to the right side. Why not? Since the x is over there already. I'll say minus 3x minus 3x. Oh, put my process line, and those 3's cancel. The negative 9 comes down. 2x minus 3x gives me negative x. And then just divide or multiply both sides by negative 1. And we are going to get 9 equals x. All right. Awesome. And I think that finishes up.
I have a quick question on that one.
Yes, go ahead. Go ahead.
So whenever we have the answer as 9 equals x,
Mhm.
is it okay if we write it as x equals 9, or do you want us to keep it
No,
in the
if
same?
you want to switch it over to x equals 9, that's totally fine. They both mean the same thing.
Okay, I just want to make sure.
No,
Thank
you're
you.
good. Yeah. But if it's hurting your brain so much you need to switch it, that's fine.
I guess it's just like the writing of x equals whatsoever, and I'm just like switch it.
Yeah. No, I get it. I get it. Yeah.
Thank you.
Yeah, for sure. Okay. So that finishes these notes finally. Order of operations, solving linear equations and expressions. Okay. Any questions on these notes? Oof. It looks like a lot, right? Okay, then. Let me stop recording on that.